Welcome to our review on cracking oil fractions. So the first thing we actually need to understand is what the problem that we end up with as a result of fractional distillation actually is. So what I've given you is a typical graph that they like to use on the exams, which shows you the supply of the different fractions and the demand for each of those fractions. And as you look at it, hopefully what you can see is that the demand for certain fractions, like our petrol and diesel, is actually greater than the supply we have. Whereas for the paraffin, the heating oil and the fuel oil and bitumen, then the opposite is true. The supply is much greater than our demand. In order to deal with this problem, we can carry out a process called cracking. And cracking converts large alkane molecules into the smaller, more useful hydrocarbons, the alkanes and the alkenes. In order to carry out this process, we need two things. Firstly, we need a catalyst, which is usually silica or alumina. And secondly, a high temperature of usually between 600 to 700 degrees Celsius. Now, when we take something like octane, which is a large alkane, it's got 8 carbons in it, and we have the catalyst and the high temperature, we can actually split that octane into hexane and ethene. So we're splitting it into an alkane and an alkene. And as a result of carrying out this process, we can actually match supply to the demand, because what we're doing is breaking those covalent bonds between the atoms to make smaller hydrocarbons of the ones that we actually need in greater amounts than we get through fractional distillation on its own. You may well have carried out your own cracking experiment out in class. So you'd have had a setup rather like this. So in one tube, you've actually got little bits of catalyst, which is probably broken bits of porcelain. You've got mineral wool soaked in the liquid paraffin at one end, and then at the other end, you've got a delivery tube that then goes through into another test tube. So what we actually find here is, as we heat both the catalyst and the mineral wool soaked in paraffin, then what happens is the paraffin itself is going to be broken up into smaller hydrocarbons, the alkanes and the alkenes, which we can collect in the other tubes. Now, the reason that we don't just use fractional distillation and then use these long chain alkanes for whatever purpose we needed is because they're not overly useful. They don't flow easily because they're quite thick in their actual nature, and they're rather hard to ignite, so we can't burn them as easily as we can the shorter chain alkanes. Now, in fractional distillation, as we've said, what we're doing is we're producing more of the fractions that have got these large molecules there and high boiling points than we can actually sell. And we're not making enough of the small molecule fractions with the low boiling points that are in high demand. So by using cracking, we can match the supply to the demand. And the ability to do this is incredibly important to us, because 90% of the crude oil that we actually use is used to produce fuels like petrol and diesel, which, as we've seen, isn't in high enough supply to meet our demands without cracking. Anything that's left over, we use that last 10% in the chemical industry to make all these products like the polymers which we use in our everyday lives. Hopefully at the end of the video you can now describe the process of cracking, you can explain why we carry it out, and also explain how our modern life is very dependent upon these hydrocarbons.